Well, it is time for our closing keynote, and I'm here to introduce Rodney Brooks. Rodney Brooks is the Panasonic Professor of Robotics Emeritus at MIT. He is the former director from 1997 to 2007 of the MIT Artificial Intelligence Laboratory and then the MIT Computer Science and Artificial Intelligence Laboratory, otherwise known as CSAIL. He received degrees in pure mathematics from the Flinders University of South Australia and a PhD in computer science from Stanford University in 1981. He's a robotics entrepreneur and is currently the CTO and co-founder of Robust AI. He is also the founder of Rethink Robotics and iRobot. He is the founding fellow of the Association of the Advancement of Artificial Intelligence, AAAI, and a member of many other technology-oriented organizations. He has won many awards, including the Computers and Thought Award at the 1991 International Joint Conference on Artificial Intelligence. Please join me in welcoming Rodney Brooks.
Well, is this on? Can you hear me? Yeah. So, thanks for that introduction. That just shows that I've been around a long, long time. And I just want to say a couple words about that, because I'm going to sound a bit pessimistic. It's going to here, but I'm actually very optimistic. Throughout my career at the top line, I came up with all sorts of robots that interact with people in interesting ways. And in the bottom line, some of the commercial robots that I've developed, including the Roomba. I like to say I did my degree in pure mathematics, and I ended up being a vacuum cleaner salesman. But that's the way it is when you're an entrepreneur. Okay, I guess these don't work. Right now, I'm working on robots for warehouses. DHL is our big customer, DHL Logistics. And again, trying to make the robots comfortable for humans to be around. So the form factor we use is not humanoids walking around. Even though I have built and delivered more humanoids than anyone else, they're like carts. They're like shopping carts. What's a shopping cart got? It's got a handlebar. So if there's a problem with the robot, grab the handlebar and do what you wish with it. So I always try to make technology easy for people to understand, and therefore we can deploy it at scale. And with always looking at the business case, the return on investment is very important. These are numbers from DHL, from running our robots. But what I'm really here to talk about is how good is AI? And I've heard a lot of different things today. I've heard people be realistic about AI and a little bit of excitement about it's the great big next thing. Well, AI has always been the great big next thing. These are just some that I can remember from my lifetime. Way back in 1959 when Arthur Samuel built a machine learning, and he used the word machine learning in his paper to play checkers, and it beat the Connecticut state champion. Oh my God, computers can beat the Connecticut state champion in checkers. It's the end of the world. AI is going to take over. And so on. Some of you may remember when Kasparov was beaten by Deep Blue in the 1996, and the New York Times said it's over for humankind. It's just going to take over. Here's one that's more recent. Some of you may remember in detail. Oh, this is just what the world feels like to me. It's the end of the world. AI is going to do this. AI is going to do that with every new technique. But here's one that's more recent. This is February 2011, story by John Markoff in the New York Times, when IBM's Watson beat the champions for Jeopardy. And everyone thought things were going to change. Here are 3 consecutive paragraphs from that article by John in 2011. And I think it's interesting if you replace IBM with Microsoft and replace Watson with generative AI in this story. It reads pretty damn well. So in that first paragraph there, it's taken a big step towards a world in which intelligent machines will understand and respond to humans, and perhaps inevitably replace some of them. And then Watson is a question-answering machine, a computer akin to the one in Star Trek that can understand questions posed in natural language and answer them. You've heard of that recently, right? And third paragraph, Watson, it's imperfect, but researchers at Microsoft, IBM, whatever, OpenAI, are going to fix all that. It's going to be great. Here's two more paragraphs. These were not consecutive, but elsewhere. For IBM, the future will happen very quickly. Here's some announcements coming up. Towards the end of that paragraph, the company plans to work with nuanced communications to add voice recognition. Does anyone remember what happened yesterday? ChatGPT 4.0, it now has voice interaction. 18 months after ChatGPT 4 was first announced. 18 months. This story just works. Just substitute them. It works. IBM executive also had discussions with major consumer electronics retailer. So it'll interact with consumers on a variety of subjects like buying decisions and technical support. This stuff, this Watson stuff, is going to be great. It's going to change everything. That was February 2011. Here we are, September 2017. Maybe Watson can do advertising. Maybe it'll be good at that. Yeah, actually, did I say that? Somewhere, yeah, it said it was going to change medicine, didn't it? Somewhere in there it says, at the bottom, change the way doctors practice. Yeah. So September 2017, maybe it can do digital marketing. This is June 2018. It's not working out so well for health. And this is August 2018. It's all over. 7.5 years later, it's gone. Just keep that in mind, okay? I'm not saying it's going to be over, but just keep in mind how everyone gets excited about stuff. People may or may not remember that the key thing about self-driving cars happened in 2007 with the DARPA Urban Challenge, with a lot of cars driving around with each other. This was 20 years in, by the way. The first time I sat through a presentation of a self-driving car on the Autobahn in Germany was back in 1987. So it took a while to get to this, but then everyone said, self-driving cars are coming. This is a snapshot I took in March 2017. Each line there is a specific prediction by a specific company. The parenthesis is the year it was made, and the blue date. So let's look on the fourth line. Ford CEO announces fully autonomous vehicles for mobility services by 2021. And I've pinked out the dates that have passed. Every date that's passed, it didn't happen. The orange arrows are where I remember the company updating their predictions. And I took my first ride in a Waymo in 2012. I took over 40 rides recently in cruise vehicles, and some of you know that they were the last two people standing in the US. Cruise is now gone. Waymo's laying off people. Ooh, do you remember when, did any of you, just a handful of years ago, people were saying, it's great, my teenagers are never going to have to learn to drive. It's going to be autonomous driving everywhere. It didn't happen. So why are so many so wrong? And I think there's two things. One is fear of missing out. No company wants to say, we missed it. But the next one, and this relates to what Akira mentioned in the last talk. It's fear of being a wimpy techno-pessimist and looking stupid later. No CIO can afford to say, yeah, well, I should have seen it coming, but I didn't. So you got to get in there. You got to be in the game because you don't want to appear to be the dumb one later. It's not an economic reason. It's a pride reason. FOMO is economic, the greed, but the next one is pride. So I have developed 3 laws of artificial intelligence. I only published them for the first time 2 weeks ago, but I mean, they fit with what I've been thinking about for a long time. And I think these are important to understand what's going on with AI in general for the last 70 years, since 1956. The first thing is, when an AI system performs a task, human observers immediately estimate its general competence in areas that seem related. And we do this because we do it with people all the time. We evaluate people. We see them performing a task, and we evaluate how good they are, how much we should believe them, how smart they are. But the relationship between performance on one task and general competence in an AI system so far has been very different from the relationship between performance on one task and general competence in human intelligence. And so that inference is not necessarily right, and it usually overestimates, overinflates the estimate of how generally competent the system is. Second thing is, this was again referred to in a number of talks today, most successful AI deployments have a human somewhere in the loop. Maybe it's the human being helped, and that the human intelligence smooths out the edges. So I suppose some of you can remember back to the olden times when Google search results were not all ads for the first 60 or 80 things. There were just 10 pages that came up, and you scan down, oh, that fourth one's pretty good. Yeah, that's what I want. Even if the first one wasn't right, even if its ranking excuse me, wasn't correct, your human intelligence was in the loop. So most AI systems, and there was some talk about this just in the last session with medical stuff, having someone evaluate the results of the LLMs. Third one is we have to box in how an AI system is deployed because there's a long tail of special cases, which again, there was a question from someone in the last session about changing the cases by hand when the doctor could override and figure out what was going wrong. But in the general case for generative AI, all those fixes for the long tail tend to be AI complete. And if you could solve all them, the system you're trying to fix and box in isn't necessarily necessary. I'm not saying LLMs are not important, but we have to be careful how we evaluate them. And I had previously published in Technology Review the 7 deadly sins of AI prediction. I'm going to tell you about 2 of them quickly here. One is people often can't distinguish, or let me tell you, here's Arthur C. Clarke, science fiction writer, any sufficiently, third law, ignore that first law, please ignore the first law. Any sufficiently advanced technology is indistinguishable from magic. If it's too advanced, you can't evaluate it one way or another. So let's have some other magic. That's TARDIS, the time machine from Doctor Who. Let's go back and kidnap this guy, Isaac Newton. Actually, let's kidnap the older version of Isaac Newton in the time machine, bring him into today's time. Let's put him in the chapel at Trinity College in Cambridge. It hasn't changed much since he was an undergraduate there in 1655. We can turn off the electric light. It'll just be the same. He thinks he's hanging around. Now, you remember Isaac Newton? He invented calculus. He figured out gravity. He was professor of optics. He was master of the mint. He was a pretty smart guy. So let's give him an apple. Oh, no, that was the gravity stuff. This apple. Give him this apple. And, it's glowing. Now, for Isaac Newton, what was the source of light? It was things up in the sky, the sun, the moon, the planets, or fire. That's the 2 sources of light. And there's this thing glowing. Let's play him a little movie of some animals frolicking around. Let's make a movie of him. Play it back to him. Oh, then let's show him on the screen one of his publications. Actually, let's show him one of his actual publications that he has hand annotated. So it's his handwriting in this machine, glowing light with no fire. Is he likely to think, oh, the battery life of this thing must be terrible? No, he has no way of understanding the limitations of this technology. It's just complete magic inexplicable to him. We have that same effect with ChatGPT. Here I asked it to write a sonnet about what is a robot based on Shakespeare's Sonnet 18. Immediately it came out with this: shall I compare thee to a robot's grace, etc., etc. Man, it understands language so well. Surely it can talk about anything. You know, it can talk about anything, but it confabulates, and always will without extra mechanisms. That gets back to extra mechanisms. I want to quickly say another thing we have been trained to do is exponentialism. Ever since Gordon Moore published his paper in 1965 with 4 data points about how circuits were going to get better, and he had the temerity to predict out 10 years in the future, turned out to be good for 50 years. We have just thought technology just gets better and better all the time. This was my exponential marketing for CSAIL back in 2007. I pointed out the $400 iPod had memory going from 10 gigabytes to 20 to 40 to 80 to 160 gigabytes, and I was trying to scare companies into sponsoring us, because what were they going to do in 2017 when the iPod had 160 terabytes? In fact, there were only 2 models, and one had 160 gigabytes and one had 256 gigabytes. It stopped. The exponential stopped. But we've gotten used to thinking, well, if it's starting to go up like a little bit of a hockey stick, it's going to keep going and it's going to beat human level performance. But in reality, it often goes like that. In the case of the iPod, it stopped because 160 gigabytes was plenty for everyone's music and photos. You didn't need more. So sometimes there are limits to growth, sometimes economics stops it. Perhaps it wasn't really exponential anyway. But we're just trained to think, and you hear that, oh, this is exponentially better than that. 2 things you can't compare that way. And exponential equivalences, just because you have more computation doesn't mean it's going to be smarter. The elephant in the room, oh, please draw a room with absolutely no elephants in it. And this is what DALL-E does, because you mentioned elephants. It's like a 2-year-old. Elephant, oh, elephants, must be. So it's important to understand what generative AI is. And I know all of you do, but here's my advice for getting other people in your company to understand it. The minimal reading, not the stuff under his left arm, just the stuff under his right arm. It's his, what is ChatGPT, that's Stephen Wolfram. And if they're really good, give them the GPT-4 technical report from about a year ago. And Wolfram's little pamphlet, which is a website, but also a book, What is ChatGPT and what is it doing and why does it work? And Sam Altman on the back cover says it's great, and it is great. It's really good for understanding. So I recommend showing that to other people in your organization when they're asking you, why can't you build this thing that can do X with ChatGPT? And try to give the limitations. And you know, he starts out and says the critical thing, and this is remarkable. I'm not being negative about large language models. They are astonishing in what they can do and surprised us all, as did many other innovations over time. But all it's doing is just over and over again, given the text so far, what should the next word be? And this is a little diagram, time going left to right, from a paper in Nature last year. Prompted the system, tell me about it, write a fairy tale. It said once upon, what's the next word? Once upon a, what's the next word? Time. Once upon a time, what's the next word? There. It's got to be a king or a dragon or something. You may have seen recent paper just two weeks ago. What if instead of doing one word at a time, we do whole phrases at a time? Drastically increases the performance of LLMs if you do that, with some restrictions. But it's just what's the next word. So there's no surprise that you're not getting reasoning coming out of this. And everyone wants to say, oh, but it's like it's reasoning. It's not. It sometimes appears like it's reasoning, but it's not doing the hard stuff. This, by the way, is the key paper from 2017, and it's just this bunch of feed-forward linear neurons. I said in 2018 that I didn't know what the next big thing would be, but I guaranteed that the critical paper had already been published. So I was lucky, it was only a year earlier. But there's going to be a next big thing, gang. The critical paper has already been published. The problem is there's 100,000 papers that have been published, and we don't know which one is going to be the next big thing. But there will be a next big thing. I'm going to skip quickly over that and get to what Alison Gopnik at Berkeley and her students say. They're an amazing thing, the way there is correlation in there which we did not expect from pure symbols, pure tokens in language. But they can't do a lot of stuff that every human child can do. Alison's lab studies children, evaluates them. This is a long tail of special purpose reasoners, and you've heard some people talk about some of those things today. For logical inference, to check it, for deductive reasoning, temporal reasoning, genealogical reasoning, all those sorts of things to get around the weird problems that happen. So there is a technology, but it is not general purpose AI by any means at the moment, and it won't be without a lot of other work. This, by the way, has been the subject of traditional AI for the last 70 years, and it needs to be patched around our LLMs to work out. So need all these to keep confabulations in check, and I'll leave you with my 3 laws. My time is up. Thank you very much for your attention. And I'll be around so you can come and Michael can come and yell at me, other people can agree with me, but thank you.